Up next, I would like you to remember this rule, which is known as all students take coffee, where all means all trigonometric functions are positive. The S represents the sine theta, T for tangent, and C for cosine. Besides that, their inverse functions would also be positive in the respective quadrants. For example, the inverse of sine theta is cosecant theta, and hence cosecant would also be positive. Now, other than these two ratios for the second, third, and fourth quadrant, all of the remaining trigonometric functions would be negative in these quadrants. And if you remember that line, all students take coffee, it will just take you a minute or maybe 30 seconds to determine which quadrant had a positive or negative value. Let's consider an example. What would be the sine of 150 degrees? Would it be positive or negative? So since 150 degrees lies in the second quadrant and sine theta is positive there, the answer would be positive. Now, what about tangent 330? It's the fourth quadrant, and we can see in the fourth quadrant only the cosine and its inverse is greater than zero, and all of the other are negative. And now we must explore the most common identity questions in LCAT, which means simplified expressions using core trigonometric identities. Let's start with the Pythagorean identities. The most famous one. Then we also have one tan squared equals secant. These three allow you to convert between ratios instantly. For example, and and you need to find the secant squared here. Okay. So first of all, you need the tan square in order to use the second identity. And now by substitution, you get which will give you the value as 25 or 16 for secant square. and hence the secant 5/4. Quotient identity. We also have these engines which we call them as quotient. Similarly, for example, first of all, you would simplify the expression by cancelling out the common terms. And since sine square theta or sine theta whole squared both are the same expressions, hence after this conversion, we can now get rid of sine theta and the remaining expression is equal to tangent theta by using the first identity from the quotient list. Angle complement identity. It's very important because LCAT uses them often. Similarly, cos of sine theta. So you can see that after 90 minus theta, the sine converts to cosine and vice versa. And also the tangent converts to cotangent. Hence, if you have an MCQ like this, sine of 30 would be same as sine of 90 minus 30, which is same as cosine of theta, where theta is 30. It should be 90 minus 30, which is 6. But yeah, in this case, this theta is different, so let's call it phi, or maybe even the same thing. Oh, I think I made a mistake here. It was 90 minus 60 because 30 would be equals to 90 minus 60, and hence this angle was the answer. So yeah, it was the correct one. We have theta. However, let's consider another example. Tangent 20. So first of all, we'll write it down in 90 minus theta. So 20 would be 90 minus 70. As it would be equal to part of theta, which is 70 here.